All right, so this video is going to focus on 7.5. And the first thing I want you to do is I want you to think about the Pythagorean theorem. I have two different kinds of triangles here. I mean, they're all right, of course, but this one here has the legs, and I want to find the hypotenuse. And this has a hypotenuse and a leg, and I have to find the other leg. So in this case, I'm adding my sides and finding my hypotenuse. This one, I'm taking my hypotenuse and subtracting a leg to figure out the area of this leg, which will then give me the side length. So pause the video and try to figure it out. All right, so here are your values. What are some other ways you could use the Pythagorean theorem? I mean, there's two other ways, and that's what we're going to focus on in this. Number one, we could actually prove if a triangle is a right triangle using the Pythagorean theorem. For instance, if I told you that this was 4 and this was 3, and I said this was equal to 7, okay? Now we can prove this, if it's true or not, if it's a right triangle, because check this out. What is 4 times 4? 16. What is 3 times 3? 9. So if I add these together, I get 25, right, collectively? But when I add this up, 7 times 7 is 49, and 25 does not equal 49. Therefore, this is not a right triangle. So pretty easy. I mean, you just kind of go through and see if it's a true statement or not. In this case, it is not. And that is how the Pythagorean theorem will help me prove whether something is a right triangle or not. Another thing we can do with the Pythagorean theorem is actually find the distance between ordered pairs on a graph, which we'll get to later on as well. But before we get to that, we're going to talk about converse statements. Converse statements are actually pretty easy. They seem kind of complicated at first, but it's basically looking at a statement and saying if A equals B, so let's just pretend that 3 equals 3, right? So A is 3 and B equals 3. Then A squared equals B squared. Let's look at it. So 3 squared is 9, and then 3 squared is 9. So 9, that's a true statement, right? But the converse means let's now flip the order. So I'm going to write this down. A squared equals B squared. Therefore, or then, A equals B. And we'll see if this is always true, right? So I just flipped the order of these things to see if it was still a true statement. Well, if I have this and I said that it's negative 5 squared equals 5 squared, that is absolutely a true statement, isn't it? They're both equal to 25. But negative 5 does not equal 5. So this converse, when I do it, it does not hold true, so this is a false statement. Okay. Whereas if I look at another one, or let's look at this one here, A equals B, and then I have my A cubed equals B cubed. This one doesn't really have the same thing I just did, because check it out. If I have, let's say, 5, so A equals 5, B equals 5. Of course, this will both be equal to 125, but now let's flip the order and say, okay, so A cubed plus B cubed equals, or I'm sorry, A cubed equals B cubed, then A equals B. Let's just see if that's true. Let's try flipping the order like I did last time. So I said negative 5 and positive 5, right? Well, negative 5 to the third power would be negative 5 times negative 5 times negative 5, which would equal a negative answer, negative 125. And this one here, if I put a 5 down, would be a positive answer. So I can't do what I did last time. They both have to be the same, right? Otherwise it won't be true. So if this is true, then this is true, and this is a true statement. So I can't mix it up like I did in the last one. If one translation of another figure, then the figures are congruent. So that means if I take an image and I translate it over here, it's congruent. That means I move the same image, and that's true. Now the next one says, if two figures are congruent, if I flip it, then one figure is a translation of another. Well, not necessarily. I could have two images that are drawn that weren't actually moved. I mean, they were the same. So this is a false statement. If two triangles are similar, then the triangles have the same angle measurements. So if two triangles have the same angle measurements, then the triangles are similar. That's a true statement, both ways. The next one here is we're going to look at this right here, and we're going to take a look, and it says consider DEF, whose side length is ABC, such that a squared plus b squared equals c squared. Also consider this one. So it's the same thing where this is an angle measurement of 90 degrees. What does the Pythagorean theorem tell you about JKL? So if I look at JKL, it's telling me that this leg plus this leg equals the area of this leg plus the area of this leg will equal the area of this hypotenuse, right? That's what it's telling me. For what does it tell you about C and X? These look like they're the same triangle, right? So C is equal to X. What does this tell you about DEF and JKL? That they're congruent. What does this tell you about side E? Well, if I look at the corresponding angle on this triangle, it's 90 degrees. So E must be 90 degrees as well. And what can I conclude? That these are both right triangles. All right, so the next one, I have choose 2 points that do not lie on the same horizontal or vertical line. And I'm just going to quickly draw out 2 points. I'll put one up here, and I'll put one down here. Okay, and now it says draw a line connecting the points. All right, cool. So let's draw a line connecting the points. I'll use a different color. And now it says draw a horizontal and vertical to form the leg. So I'm basically making a triangle. Going down. I'll use another color here. Okay, pretty close. So using this triangle, can I find distances? I mean, I don't have numbers here, right? So my ordered pair for this one is going to be 4, 5, right? I'm going to write that down. 4, 5. In fact, I'm going to write it on this side. So I'll put down 4, 5. And then this ordered pair is going to be 1, 1. And then if I put a little ordered pair right here, this ordered pair is 4, 1. And what I basically want to do with this is I want to find the distances between these things, right? If I want to find this green line, I want to find the distance from 4, 5 and 4, 1. So I'm going to look at 4, 5 and 4, 1. Now the 4s are the same, so I mean that's not moving. But what is changing is the y value, how much it goes up and down. And if I take 5 minus 1, I get 4. So this length is equal to 4. That makes sense. Look. 1, 2, 3, 4. Cool. The way that we say this is we'll say x and y, and I'll call this x and y 2, and x and y 1. And what we just did is we took y2 minus y1. That's all we did. Okay, pretty easy stuff. Now we're going to figure out this one on this side. I want to find the distance between 4, 1 and 1, 1. So I'm going to put down 4, 1 and 1, 1. And again, I'll put x2, y2, x1, y1. And I'm just going to subtract. These are the same, right? The 1. That doesn't change. But what does change is this here. So I'm going to say 4 minus 1 equals 3. And if I look here, the distance between here is 3. So that makes sense. So far I found the distances 4 and 3. And now I want to find the distance between these points up here, right? And so when I do that, I'm going to put my ordered pairs down. And I'm going to have 4, 5. So 4 and 5. And the other one is 1 and 1. Now, you'll notice on this one, what's different about it when I do x2, y2, x1, y1. In the other ones, I had the same value. Remember this? I had like 1 and 1, or I had 4 and 4. These will have different values for both of them, won't they? So my y value will be 4. The change is 4. And my x value is going to be a change of 3. Well, what we're basically doing, just so you know, is if I go up here and look, I'm figuring out that this is 4 and this is 3. And I'm almost going to do the Pythagorean theorem, right? So if I take these numbers and I square them, and I add them, this is the Pythagorean theorem. 4 squared is 16, 3 squared is 9. So this equals 25 altogether. And I do the square root of it. I now know that this equals the square root of, or this equals 5, this distance. And I did that because I knew that this height was equal to 4, and this width was equal to 3, and I just did the Pythagorean theorem. And this is called the distance formula, which we'll get to in just a moment. So let's look here, kind of reviewing what we've talked about so far. If I know that a squared plus b squared equals c squared, the converse of that means that if this is true, if c squared should equal a squared plus b squared, if that does not happen, it is not a right triangle. So an example here is this right here. Let's go through it. And if I just take 9 times 9, and I get 81, and I take 40 times 40, and I get 1600, well, that should be 1681 altogether, right? 1681 when I add them up. Well, if I take the square root of 1681, and let's just quickly do that. I don't know what that is offhand, but it should equal 41, right? So let's just do square root, and I get 41. So if I look here, let's see if that was true. Yeah, 41. So this is a true statement. This one here, I'm going to do the same thing where I take 12 squared, 18 squared, and that should equal 24 squared. So if I do that, I have this right here. I have 144 plus 324. If I add these together, I mean, just looking at the 4 and the 4, that should be an 8. And it's a 6. So this is not equal to each other. So this is not a right triangle. Tell whether this is a right triangle. So if I look here, I know my longest side is a hypotenuse. So it'd be 20 squared plus 21 squared, and that should equal 28 squared if it's a right triangle. This one here, the longest side length is 1.25. So this squared plus this squared should equal this squared. And in this case, this is a yes, and this is a big old no. The distance formula is what we talked about before. I don't know if you noticed it, but I have this x squared, y squared thing. And this is the formula. It looks really complicated, but we actually did it just a moment ago. And it wasn't that hard at all. You found the difference between the x value and you squared it. Remember, I had like the 3 and the 4. And the 3 squared was 9 and the 4 squared was 16. I added those together and I got 25. And then you take the square root of that, and that's how I got my 5. You can rewind the video and see that. All right, so this problem will ask us to find the distance formula between 1, 5 and negative 4, 2. And if I look here, remember the formula is x subset 2 minus x1 squared plus y subset 2 minus y1 to the second power, and then the square root of that. And all that we're doing, real quickly, just so we understand what this is saying on the right-hand side, is we're going to write our ordered pairs. And we'll just say 1 and 5. And it looks as though they're calling 1 and 5 my x1. So I'll say x1, y1. And then they're calling my negative 4, negative 2, my x2, y2. And if they're taking x2, which is going to be negative 4, minus, because it says you do minus, and then we'll do x1, which is 1, so that's why they get the negative 4 minus 1, and then we square that, plus negative 2 minus 5 squared. And if I add these together, because it's everything in the parentheses, so this would be negative 5 squared. This right here, negative 2 minus 5 is negative 7 squared. Now we're going to go through here and square them, and I have 25 and 49. Altogether, that equals 74. So the square root is 74. And that's my distance between these two ordered pairs. So on a graph, we just did something kind of crazy. We had these ordered pairs of like 1, 5, let's say it's over here, and we had negative 4 and negative 2, which is like down here. And you just took those ordered pairs, and you figured out the distance between this point and this point utilizing this formula. And really what we just did is the Pythagorean theorem. So it says here, you design a football play in which a player runs downfield, makes a 90-degree turn, runs to the corner of the end zone. Your friend runs the play as shown. Did your friend make a 90-degree turn? So we have to basically look here and figure out what the length of this is, figure out what the length of this is, and then we can figure out the length of this. And if they all work, if all three sides work when I do it, it is a 90-degree angle or a right triangle, right? So let's just go through and start doing this. Takes a little bit of time. But the first one is I have to figure out this length right here, right? And I'm going to do, if I look here, I'm going to take 60 minus 30. That's my x terms, right? So I have 30. Oops, sorry, 30. And I'll square that. And then I'll say plus, and then I'm going to do my other one, my y value. So I'm going to have my 50 minus 20. And that equal 50 minus 20 is also, so 50 minus 20 is also 30. So squared. So I have 900 plus 900. And then that's 1800. And I have the square root of that. So this length from here to here is 1800. Okay? So let's just write that down so I remember this. Okay, well, there it is, 1800 feet. Now I have to figure out this one over here. And so I'll be doing the same kind of thing that I just did a moment ago. And now I'm going to take 80 minus 30, which is this one here. And I get my 50. And I'll take 30, or negative 30, minus 20, which is negative 50. And I'll square both of these. And that will equal 5,000. So this length is square root of 5,000. So right now I have this triangle. And if you think about this for a second, I have, this is square root 1800. This is square root 5,000. If I would square this, so like square root 1500 times square root 1500 equals 1500. So this is just 1500 for the area. And this is just 5,000 for the area, right? Because 5,000 times square root of 5,000 times square root of 5,000 is 5,000. Now I got to figure out the last side. So this would be 60, or you can do 80 minus 60, which is 20. And then you can do negative 30 minus 50, which would be negative 80 squared. And that's 6,800. So let's check this out for a second. I have this side here, 1,500 plus 5,000. If I add those together, does that equal 6,800? And the answer is no. It's actually like 300 off, right? Wait a sec. So I had 5,000. Oh, that's an 18. My bad. So that's 1,800. So 5,000 plus 1,800 equals 6,800. This is a good example of why you have to write clearly, otherwise you might make a mistake. I thought this was a 1,500. Oh boy. So find the distance between these 2 points. So if I look here, let's try doing it. So remember, we're going to take like 4 minus 0 squared and 5 minus 0 squared. And if I do that, I'm going to have 16 plus 25 equals 41. And I will do the square root of that, which equals, well, that's the square root of 41. And you do that for all these, right? And that's really the lesson.